Okay, so in this exercise 4, we need to calculate a couple of elasticities for a total of 3 different demand functions. And once we are supposed to use the percentage change formula, and once the arc elasticity formula. And you see, once we lower the price from 7 to 5, then from 5 to 3, then from 3 to 1, but then we also go back up again. So that's quite a lot of work, and in order to simplify that a little bit, what I suggest is that I'll illustrate everything in Excel. So I copy everything from the Word file and I paste it into an Excel sheet, and I hope that this makes it a little bit easier. So okay, so now we can see everything. Okay, so we always have price changes, old to new. Okay, and then what we need to do is, from looking up the inverse demand function associated with the price changes, we need to look up the new quantity and the old one. And then we can actually use just a formula in order to calculate the elasticities, and that should make it a little bit easier. So let's start with the first formula, or the first demand. So the first demand function is P equals 8 minus Q. So let me insert that here. So it starts at 8. And has a slope of -1, so this goes from 8 to 8. And we can make it a little bit bigger. Okay. So now, if we lower the price from 7 to 5, so at 7 the old quantity demanded is 1, and at 5 it is 3. So now we can write here 1 and 3. Now if we lower the price from 5 to 3, then the old is 3 and the new one is 5. So 3 to 5. Now we lower it from 3 to 1, so then it goes from 5 to 7. Okay, so now if we go up from 5 to 7, then we move from 3 to 1. So it's the inverse of the first case. So the old is now 3, the new is 1. Now we go from a price of 3 to 5. So now we go from 5 to 3. And the last one is, we go from a price of 1 to 3, and so that means we go from 7 to 5. Okay. Okay, so now we have the new price and the old price. So now the percentage change formula, so again the elasticity in general terms was, we're going to put it maybe here. So elasticity using the percentage change formula is the relative change in quantity demanded. So we have Q new minus Q old divided by Q old. And now we do the same thing for the price. Price new minus price old over the old price. That will give us the percentage change formula. So now we just can enter that. So now we use first the denominator. So we always use the new minus the old divided by the old. So now this was the numerator. So let's put another parenthesis around there. And now we divide by the denominator. So let's open two parentheses. So now we do the same thing. So we take the new price minus the old, close parentheses, divided by the old, close parentheses. So now we should see a negative number, which is -7. So the elasticity is very elastic because it's up there. So now the good thing is, because I always use the same formula here, I just can copy that down. I copy that down by double clicking into that little box here. So now maybe I can remove some of the decimal points. And okay, so now we have, and you see, as we move down, the price elasticity decreases. So, okay, and again, what you also see is, for example, if we lower the price from 7 to 5, but then we increase it back from 5 to 7, we get different numbers. So this is what we don't like. So therefore, let's use the arc elasticity. And the arc elasticity is very similar, but the only thing that changes is here the denominator of each of the relative change. So for the arc elasticity, we have to put here the midpoint between the new quantity and the old. So we have to use the respective midpoint. And then we should avoid the problem that when we lower the price from 7 to 5, we get -7. But if we increase it back from 5 to 7, we get -1.6. So when we want to do the arc elasticity, so now we say again the new quantity minus the old, but now we do not divide by the old, but by the average between the 1 and the 3, which is the midpoint. So now we divide by the average of these two values. Okay, so now we have to close. And now we divide again. Open two parentheses. So now we take again the new price minus the old, close parentheses, and now we divide by the average of those two, which will be 6. Okay, so now, so we get here -3, and now I can copy down that formula again. And now you see when we lower the price from 7 to 5, we get -3. And if we go back up from 5 to 7, we get again the -3. So we get the right we get the same elasticity, which is what we like. Okay, so now let's maybe illustrate it by reducing some of the decimals. Okay, so now let's also I have to still make sure that the table looks nice. Okay. Okay, so now okay, good enough. Okay, so now we take the second demand function, which is 8 minus 2q. So 8 minus 2q means that the slope is 2. So that means it goes from 8 to 4. So now all we need to do is we now just need to identify the new quantities and the old. So we lower the price from 7 to 5. So the old quantity is at 7. Well, that is 0.5. The new is at 5 is 1.5. Then we take a look at 5 to 3. From 5 to 3 we have here 1.5. And then at a value of 3 we have 2.5. And then from between 3 and 1 we move from 2.5 to 3.5. Okay, so now we go up again, 5 to 7, so we just flip from 1.5 to 0.5, then from 2.5 to 1.5, and lastly from 3.5 to 2.5. Okay, so now we have again the same. So we have identified the, I can take this one here presumably, good. Okay, so now the good thing is we have the quantities. So now what I can do is I just can take those formulas and it will pick it up right here. So if I copy this formula into this cell, it picks up the formula, but of course it will change now the formatting of the background, but that's not a big deal. But now we have all the formulas. And you see, if we lower the price again from 7 to 5, with the percentage change, right, the different formatting drives me nuts. So let me quickly just, okay. Okay, so now we see when we lower the price from 7 to 5, if we lower the price from 7 to 5, we get a percentage elasticity of negative 3.5. If we increase it back from 5 to 7, we get 0.83, a different value. But when we use the arc elasticity, lowering the price from 7 to 5 is negative 1.25, and increasing it back from, oh, that's different. Oh yeah, okay. So now we can see what's wrong. I should have, of course, in the formula here, because the price stays always the same, I forgot to put in front of the new, of the old price and the new price, which is the cell A3 and B3, I need to make sure that I put a little dollar sign in front. So that when I copy the formula to the right, this doesn't change. And of course I need to do it here too. Whenever we see A or B, we need to put a dollar sign in front. So that will prevent that you see what happened is, without the dollar sign, the formula that referred to cell A and B was shifted to the right. And this is what we try to avoid with the dollar sign. So now I copy it again. And now you see that when you look at that formula, these two cells have not changed. Okay. So let's just, and now we can see that when we lower the price from 7 to 5, well, the percentage elasticity gives us a value of 7. If we increase it back from 5 to 7, we get negative 1.6. But for the arc elasticity, the values are always the same. Okay. So now let's go to the last one. And that should go fast. So 8 minus 4q. So now this is what the formula looks like. And now we can determine the old price. So at the price of 7, then the Q old is 0.25. And at the price of 5, it is 0.75. Okay. So, and then at the price of 5, okay, if we have here 5, it goes from 0.75 to 1.25. So you can also always solve this equation, you know, if the price here is 3, then the question is 8 minus 4 point what is 3, and 4 times 1.25 is 5, so 8 minus 5 is 3. So it requires a little bit of math, but we can also sense it from the graph. And again, I'm going to make sure that we always see 2 decimal points. So now we see 3. Okay. And then the next one goes from 1.25 to 1.75. And then we go backwards again. So from 5 to 7, that would be from 0.75 to 0.25. Just like flipping those two. And then we go the second one, 5.5 and 3, 3 to 5. So now we go from 1.25 to 0.75. And the last one, we go from 1.75 to 1.25, 1.75 to 1.25. Okay, so now the good thing is I just can copy that formula because I put those little dollar signs in there. So now the formulas should work. And so now you see, again, if you lower the price from 7 to 5 using the percentage elasticity formula, we get negative 7. If you go back from 5 to 7, we get 1.67. But using the arc elasticity formula, we always get the same value. And you can see that the formula works very nicely. As before, I made the mistake that I forgot to put the dollar sign in front of those columns, and then they shifted to the right as I copied the formula to the right. Okay, so the answers are basically now here, and I can copy them back here. And let's see how that best works. Probably like this. So now we have the correct elasticities here. And again, the formula is straightforward. It was a little bit tedious, but it also helped you maybe see the use of Excel in automizing things, and unfortunately it also showed you what happens when you do a mistake. But the good thing is, in Excel you can identify very quickly the mistake. So I hope that was nevertheless useful. Sometimes you can learn from mistakes too. Alright, so let's stop here, and then in the next one let's work on some other problem sets. I'll just stop here.